if you multiply, give you another polynomial. Okay. When dealing with numbers, analogously, you can talk of, for example, 40 can be expressed as 5 times 8. So we refer to 5 as 8 as factors of 40. So we want to do this for polynomials and even other expressions which are not necessarily polynomials. The first technique we use to factor expressions is by identifying common factors. So the first technique that we will learn today is factorization by common factors. Common factors. So this technique simply involves you to identify a common factor, then you pull it out. For example, let's say you are asked to factorize maybe x to the 4 plus x squared. Okay, then identify factors. So which terms or which monomials divide each of these terms. X to the 4, the factors are x, x squared, x cubed, and x to the 4. If you look at x squared, the factors are just x and x squared. Then the common factors in this case will be the guys which belong to both sides. So the common factors for this in this expression are x and x squared. Then we take the greatest common factor, in this case, x squared. So we can write x to the 4 plus x squared as x squared times x squared plus x squared. And then x squared is a common factor. So we pull out x squared. In the first term, we have x squared. In the second term, we have 1. So that factorization of x4 plus x squared is just x squared into x squared plus 1. The main idea is to identify a common factor and then pull it out. Let me give you another example where you factorize using common factors. Example 2. So suppose I give you an expression like 12 x cubed yz minus 3 x squared y squared z plus maybe 6 x y z cubed. Factorize this expression by identifying common factors. So this is how you will go about this. First of all, deal with the numbers. Okay, so the numbers we have 12, 3, and 6. The common factor, the greatest common factor, for 12, 3, and 6 is just 3, because it's only, I mean, you will have factors of 12 are 1, 2, 3, 4, 6, and 12. Factors of 3 are 1 and 3. Factors of 6 are 1, 2, 3, and 6. And the greatest of these is 3. Then we move to x cubed, x squared, and x. The greatest common factor in this case is simply x. Then you move to y, y squared, y. The greatest common factor here is y. And then lastly, z, z, and z cubed. The greatest is z. So then the product of these common factors would be a common factor in the entire expression. So the common factor we'll have is 3x, y, z. Now, how do we proceed? Pull out this factor from each expression. So we will have 3x, y, z into, so 3 goes into 12 4 times. Then x goes into x cubed, x squared times. Y goes into y once, z goes into z once. So we are done with the first term. Then we move to the second term. Of course, 3 goes into 3 once, and then x into x squared, that is just x. Y into y squared, that is just y. Then z into z, that is just 1. Then the last term, we have 6. 3 goes into 6 twice. Of course, x goes into xy. Xy goes into xy once. So we only have z cubed, which divided by z gives you z squared. And so this is our factorization of this expression. We first of all identify the common factors of the numbers, then we pick the greatest. So always look for the greatest common factor. Then we look for x, the terms involving x, x cubed, x squared, x, we pick the greatest. The terms involving y, y squared, and y, pick the greatest common factor. We look for z, z and z cubed, and we pick the greatest common factor. So then a common factor for this entire expression will be a product of this, your greatest common factor. So your duty is just to identify how this common factor divides into each of these your terms. Okay?
So I have a question.
Yes.
How is the common factor of the 12, 3, 6, 3 the largest common factor? 3.
How the largest common factor is 3?
Yeah.
Yeah, that's a very good question. So the factors of 12 are simply numbers which can divide 12 in simple terms. So this 1, 2, 3, 4, 6, 12. These are the only numbers which can divide 12. Because in this case, I'm only referring to positive integers or natural numbers. Then 6, the numbers which can divide 6 are 1, 2, 3, and 6. Of course, when I say 1 is a factor of 12, you can write 12 as 12 times 1. When I say 2 is a factor of 12, you can write 12 as 2 times 6. When I say 3 is a common factor, is a factor, you can write 12 as 3 times 4. When 6, you can take 6 times 2. Same for 12. And in a similar fashion, 6, the factors are 1, 2, and 3, 2, 3, and 6. So you can write 6 as 1 times 6. You can write 6 as 2 times 3 or 3 times 2. Their multiplication is commutative. You can write it as 6 times 1. And then lastly, 3, the factors of 3 are just 1 and 3. So then I identify the common factors, okay? Which factors are common? So we have one factor in each of the terms, okay? It's a factor of 12, it's a factor of 6, factor of 3. 2 is a factor of 12 and 6, but not a factor of 3, so it's not a common factor. 3 is a factor of 12, it's a factor of 6, it's a factor of 3. So 3 is a common factor. When you move 4, 4 is not a factor of 6, not a factor of 3. 6 is a factor of 12 and 6, but not a factor of 3. So the only common factors are 1 and 3. Then I pick the greatest. So 3 is greater than 1. That's why I'm talking of the greatest common factor being 3.
Okay, thanks. Thank you.
Or you
I have a question.
Or you can do, there was this technique we used in high school. So
GCD.
the GCD, yeah? You remember how to do this? Huh? You remember how to complete the GCD using this?
Yes.
Yes.
Okay. Of course, you will start with 2, but 2 does not divide 3. So you move to the next prime number, which is 3. 3 goes there 4 twice. And then the only factor that can now divide this is 1. So the greatest common factor will be 3.
I have a question.
Yes.
For x, the greatest common divisor should be cubed.
The greatest
Common factor for x should be cubed.
should be cubed.
Yeah.
No, because x cubed cannot divide x. Huh? X cubed cannot divide x squared. If you were to compute the greatest common factor of x cubed, x squared, and x, then the first, so x divides x cubed, x squared times. X divides x squared, x divides x once. Then there is no other expression which can divide all these guys. So the greatest factor becomes x. Remember, x cubed cannot divide x. Okay? You cannot evaluate x cubed. I mean, x divided by x cubed, because of course you can factorize this, but you cannot divide x cubed by. You cannot divide x by x cubed because the exponent of the denominator is greater than the exponent of the numerator. So the greatest factor here is x. Of course, 1 is also a factor, but arbitrary. If you talk of arbitrary values, you can suppose this is the same as 1 times x. Abdi Hakim, are you convinced?
Yes.
Are you convinced that the greatest factor here is x? Because it's
Excuse me, sir.
only x that can divide all these terms. X cubed cannot divide x squared, cannot divide x. X squared cannot divide x. So it's only x that can divide all of them. The same applies to for y's, the y's and the z's. Fair enough?
Excuse me, sir.
Yes.
Yes. Could you go over the example?
Another example.
No, this example. Could you go over it?
This example.
Yes.
Yes, we want to factorize 12x cubed yz minus that. We are to factorize this expression. And we are using the technique of common factor. So we need to identify which factor divides each of these terms, or a term that divides each of these terms in the expression. So then I said that first look for a factor for the numbers. The numbers in this case are 12, 3, and 6. And if you remember your GCD, the greatest common divisor or highest common factor of 12, 3, and 6 is just 3. Then you consider the terms involving x. So exponents of x cubed, x squared, and x. And the greatest common factor is just x, as you can see here. You do the same for y and z. And then I'm saying that a common factor for this expression will be the product of these your common factors. Take these your common factors and multiply them. So we get 3x, y, z. That will be a common factor for this expression. Then now what you do to factorize, just pull out 3x, y, z from this expression. So we have 3x, y, z. In the first term, 3 divides 12 4 times. Then x divides x cubed, x squared times. Y and z once, so we have, there's no need of writing a 1 here, though there's a silent 1 there. So the first term, we have 3x, y, z, and 4x squared. And then the second term, of course, 3 divides 3 once, and then x divides x squared x times, y divides y squared y, then z divides z just once. And then lastly, 6xy z cubed, 3 divides 6 twice, and then x divides x once, y divides y once, and then z divides z cubed z squared times. So one of the ways to check if you are right is to multiply out. You know how to multiply expressions. We did multiplication of polynomials in the last lecture. Just multiply out this and see if you get the expression that you had before. Then you will know that you have done the right factorization. Of course, someone might ask, but why do we need to factorize? Factorization helps you.
Excuse me, sir.
Helps you to simplify these problems. You might find, for example, if you're doing this in a computer, you might find that the software you're using does not accept higher exponents. Maybe it does not accept some x cubed terms. So you have to write, to break down your expression as a product of two two terms where the exponents are not more than 2. We do not have a term that has an exponent greater than 2.
Do you mind multiplying for us to factorize factors already?
Really?
Yeah.
Okay. Multiply, so 3xyz. So 3 times 4 is 12. Okay. X times x squared is x cubed. Y, then we just have yz. Right? Minus, so 3 x times x is x squared. Y times y is y squared. Then we have z, then plus 3 times 2 is 6, then x, so it's not x down, so just have xy, then z times z squared is z cubed. As you can see, we have the same expression that we had before. Are you satisfied?
Yes, I'm satisfied.
Okay, let us proceed to the next technique. So dealing with common factors, some of you might have to go and revisit your how you are doing GCD and HCF before you come to this. Of course, I know you are dealing with numbers, but the same concept applies when you're dealing with expressions. So we are going to factorize now trinomials. Trinomial is simply a polynomial that has 3 terms, okay? And firstly, we look at trinomials of the form x squared plus bx plus c, where b and c are non-zero. So remember, we want to factorize x squared plus bx plus c. Well, that simply means we need to write this as a product of 2 expressions such that the order of each exponent is less than 2. In this case is 1. So we're looking for some factors, maybe x plus, let's say, q, and maybe x plus, let's say, p. Okay? This is how we do factorization, so that each of these terms has a lower degree. Then when you multiply out this, you did multiplication.
Excuse me, sir. There's a part that you had broken up a bit. Sorry. Could you please repeat how you got to x plus 2?
How I got to x plus 2?
Yes, please.
Where?
Here.
Here.
Yes. There.
Oh, okay. Great. Great. Remember the first example that I gave you for today's class, it was x plus 1 times x minus 1 is x squared minus 1. Do you remember this example? At the beginning of the class, I was giving a
Yes, I remember.
So, and we say that x plus 1 and x minus 1 are factors of x squared minus 1, okay?
Yeah.
We want to do this in general when you have 3 terms, b and c non-zero. But remember, that is just the same as looking for a way to write this term as a product of, let's say, other terms, maybe x plus some p, where we don't know what is p. We need to look for that. And maybe x plus some q. We were lucky that in this case, p is 1 and q is -1. So you could write x squared minus 1 as x minus 1 times x plus 1. So now at this stage, just multiply what is on the right hand.
Is that a Q or a C
This is a
on
Q.
the X?
This is Q. Well, I
Yeah.
could use anything. I could use maybe, I could even use S.
Mm.
No problem. Then how do you multiply? So x into x plus s plus p into x plus s. So this gives you x squared plus sx plus px plus ps. Well, so that is simply x squared. Then x is a common factor. We've just done factorization by common factors. That was the first technique. Huh? So we'll pull out x, and then we have s plus p times x plus p s. We started with x squared plus bx c. Now,
So
these
I
two
just
expressions,
I feel like it's not that clear where you're writing because of the reflection.
is a reflection.
Yeah, or rather the light. It's a bit faint.
How about if I use this part?
Yeah, I think that would be better.
That would be better. Okay. So we want to write x squared plus bx plus c as a product of these two linear factors. But these linear factors, when you multiply them, you get x squared plus p plus s x plus p s. And I was just saying that the only way these two expressions can be equal is if the coefficients are the same. So coefficients of x squared, this side is 1. Coefficient of x squared, this side is 1. Well, that's okay. Coefficient of x, this side is b. Coefficient of x, this side is p plus s. So we must have b being equal to p plus s. The constant term on this side is c. The constant term on the other side is ps. So c must be equal to ps. This is what you guys must remember. If you are to factorize a trinomial of the form x squared plus bx plus c, well, simply look for two numbers p and s whose sum is b and product is c. Okay, look for two numbers p and s such that the sum is b and the product is c. Let me give an example. For example, let's say we have x squared plus 6x plus 9. We want to factorize this. Okay. So in this case, b is 6 and c is 9. Okay. Because your general form is x squared plus bx plus c. And we are saying you look for two numbers such that the sum is b and the product is c. So in this case, we're looking for two numbers whose sum is 6 and product is 9. Okay. And this one, you normally do this by trial and error, but after some time with experience, you will just do it automatically. So for example, the numbers 3 and 3. 3 plus 3 is 6, and 3 times 3 is 9. I already have my P and S. Okay. Maybe someone is asking, how did I get to 3 and 3? Well, that's very simple. You're looking for two factors of C, P and S. Huh? So we know, just take the factors of 9. Factors of 9 are 1, 3, and 9. Then 1, 3, and 9, and you need factors which add up to 6. Well, that's only 3 plus 3. It's only 3 plus 3 that can add up to 6. Okay. So for this case, our factorization will be x squared plus 6x plus 9 should be x plus p in this case is 3 times x plus s in this case is also 3, which is the same as writing x plus 3 squared. Maybe another example.
Please explain again. I got a problem.
Got lost where?
I got lost on how you did that x plus 3 in brackets plus x plus 3 in brackets again, because you said you prime factorizing the x squared plus the 6x plus the 9, but I'm not seeing any number out of the brackets that will multiply. I'm not seeing any greatest common factor that is gonna multiply.
We got 3 and 3.
Oh, okay, yeah.
Are you okay with how you have the 3?
But you'll get a 9 if you multiply the 3 and 3, but you won't get the 6.
Yes.
Because you said if you're to multiply your final equation, it must give you the first one, the x squared plus 6x plus 9. Is that going to give us the same?
Yes, it's true. We can try. We can do that.
Yeah, please try.
X plus 3 times x plus 3. How do you multiply polynomials? So take the first term on the left, multiply by the second term on the right, then add to second term times. So then x times x is x squared. X times 3, 3x. 3 times x, 3x. 3 times 3, that's 9. Well, then these are common terms, huh? 3x and 3x. So x squared
plus 6x plus 9.
plus 9.
I thought common terms cancel out.
Why do they cancel out? I'm adding. They only cancel out if one.
Oh yeah, sure.
One is of the opposite sign. Are you convinced? This will always work. If your factorization is right, when you multiply out the factors, you always arrive at the original expression. And this is actually one of the ways to check if you're doing the right factorization. Okay? Are we good?
Yes.
Excuse me?
Yes.
Whatever I factorize it, somebody's blocking the screen. I can't see what's on the blackboard. I mean, I wanted to ask something.
Someone is blocking the screen.
Yeah, it's now okay. Whatever I factorize it to x into brackets x plus 3, then plus 3x and plus 3 bracket x plus 3 and stop there. Wouldn't it still be the same?
We are here.
If I, no. If I stopped at the third last step where you started writing in blue.
Here.
Yeah.
Yeah, I'm not.
I mean, I factorized it already. If I'm to write it like that.
I'm not factorizing. You asked me to multiply and see if we get the original expression.
Yeah.
You asked me to expand this factorization and see if we get the original expression. And I did that and got the original expression.
All right.
Yes.
Excuse me, sir.
Yes. Go ahead.
Yes. X squared plus 3x plus 3x. You got 2x there. I'm just wondering why it's not x squared plus 6x squared. Adding the 3x together, right?
Yes, I put them together. 3x plus 3x is 6x.
I thought that because it was 2x, it would have been 6x squared.
Which x squared?
It's x squared plus 3x plus 3x.
Yes.
There are 2 3x.
Yes, 2 3. So 3x plus 3x is 6x.
So it's not 6x squared.
No, not x squared. What do you get? What do you get when you add 4a plus 5a?
9a.
9a. Not 9a squared. Huh? So similarly, 3x plus 3x is going to be 6x. that okay?
Yeah.
Okay. Let me give you another form. That was the first one for trinomial. The second form is when you have ax squared plus bx plus c is 0 and a is non-zero. So the coefficient of the highest exponent. So the highest exponent in this case is 2. We want the coefficient of this to be different from 0 and also different from 1. Because the first form we did was when a is 1, okay? So using a similar analogy as we did, just look for two terms such that the sum is b and the product is AC. Okay? We look for two numbers, maybe T and S, such that T plus S is B and T times S is AC. Let me give you an example on this. Example. So suppose you want to factorize an expression like, let's say 6x squared plus, let me see, 6x squared plus maybe 7x minus 5. So in this case, A is 6, B is 7, C is -5. And remember, this is now a situation where A is not 1. We have an A that is 6. So we are looking for two numbers, T and S, such that T plus S should be 7, and T times S should be the product of A and C. A and C, that is simply -30. So we need two numbers, T plus S, such that these two equations are satisfied at the same time. If you have done simultaneous equations, you can go ahead and solve this as simultaneous equations. But I don't want to just do that because in this case, you will end up with a quadratic and quadratic expressions.
Sorry, sir. Oh,
Go ahead, go ahead.
no, it's okay. I found my way.
It's okay.
I
Okay.
understood.
So we are looking for factors of, we're going to look for factors of -30. Factors of -30.
10 and -3.
1, 2, there's so many, 3, 5, 6, 10, 15, 30, and then -1, -2, -3, -5, -6, -10, -15, -30. This is a very small list. Let me see how many are there. This is 5, 8, 16. So these are all the possible factors of -30. You only pick 2, which will add up to 7. Okay, and this is very easy to do. After some finite number of steps, you'll realize that 7 is the same as 10 minus 3, or simply -3 plus 10. So these are the only two terms that we're looking for, -3 and 10. Because -3 times 10 is -30, and -3 plus 10 gives us 7. Well, so that means you can write 7x as 10x minus 3x. So in your expression 6x squared plus 7x minus 5, 6x squared plus 7x minus 5, instead of 7x, replace with the 10x minus 3x. So we have 7x squared, 6x squared plus, what is 7x, we replace with 10x minus 3x. minus 5. And it's not a must that I write it as 10x minus 3x. I could also write it as minus 3x plus 10x. I will get the same result. Then now group these terms. So take the first two, then the last two, and look for common factors. So our first technique was common factors. Common factors will always keep coming back in these techniques as we go along. So we're looking at 6x squared plus 10x. The common factor of 6 and 10, the greatest common factor of 6 and 10 is just 2. Okay? And then the factor of x and x squared is x. So we have 2x. Now 2x goes into 6x squared 3x times plus 2x into 10x, that is just 5. Okay? Then we move to the second group. So negative 3x and negative 5, there is only one common factor, which is negative 1. So you have minus 1 into 3x minus 5. Sorry, 3x plus 5. Because negative
I have a question.
3x negative 1 times 5 is negative 5.
I have a question.
Go ahead.
Why do we have to group them twice? Why can't we just group all of them? Why do we have to group them twice?
Yes, we have to.
Why can't we group the 6x squared with the 10x and the 3x?
Sorry, grouping 6 with 3.
Yeah, 6 with 3 and the 10x as well, all of them, and then the 5.
That will still work.
Oh.
So you're saying we have 6x squared minus 3x plus 10x minus 5. This will still work. We will get the same result. So let us do this, and then we do this, and then you will see that you get the same result. Okay. So here the common factor is 3x plus 5. Then pull out that 3x plus 5. And then here you remain with 2x. This side you remain with minus 1. So that is one way to write your factorization. If we pair 6 with 3x, then just proceed in the same way. So what is the common factor?
No, I mean, if we paired the 6 with the 3x and the 10x, is that possible?
Maybe I don't get your question. So first I paired 6x with 10x, okay? And minus 3x with minus 5. And
Okay,
now
so what I'm basically asking is,
sorry?
Okay, what I'm basically asking is, do they have to be paired into 2, basically?
Yes, they have to be paired in 2, whichever way.
Oh, okay.
Yes, they have to be paired in 2.
You can't put 3 of them in one.
No, you can't. That one will take you back to where you came from.
Oh, okay.
It's like starting a journey, and then for the end of the journey, you change your direction back to where you came from. So 6x squared and 3x, the common factor is 3x. So you factor 3x into 2x minus 1. 10x and 5, the common factor is 5. So plus 5 into 2x minus 1. And then 2x minus 1 is common. So we pick 2x minus 1 and 3x plus 5, which is the same. Because multiplication commutative.
Excuse me, sir.
Go ahead.
You had mentioned something earlier about doing simultaneous equations. Do you mind showing us that method so that just in case the looking for common factors is difficult for someone?
I don't mind showing that, but my worry is that we have not done quadratic equations. Are you all familiar with quadratic equations?
A little bit, okay, personally a little bit from high school, but I may have forgotten it.
Not at all, sir. Last time I was in school was a while back. I've forgotten almost everything.
Yeah, because we'll do quadratic equations later in this course. That's why I didn't want to talk about that method.
Okay.
For someone who remembers, this is how you will proceed.
Mhm.
Let me do it real quick. So from here, you can write t as negative 30 divided by s. I've just divided ts by s and negative 30 by s. From this second equation.
Yes, yes.
Then now, in the first equation, where there is t, I replace with negative 30 divided by s. So instead of t plus s is 7, I will have negative 30 divided by s plus s
Plus S is
is 7.
7.
Is that okay?
Yes.
Then to remove this denominator or these fractions, I multiply everything by s.
Everything by S.
So we have negative 30 plus s squared is equal to 7s.
7.
Well, this is the same as s squared minus 7s minus 30 is equal to
0.
Then you can use a quadratic formula.
Mhm.
You could also solve this by factorization, but it will take you back to the same step that you are running away from. So if you are to solve this by the formula, I hope you remember the formula.
Negative 4.
Should be 7 plus or minus 7 squared
Mhm.
minus 4 times negative 30 divided by 2. Well, so that is 7 plus or minus square root of 49. 49 plus
120.
169
169.
divided by 2. So this is
7 plus or minus 13 over 2.
2. So that s is 7 plus 13,
Either
20, that is 10.
10.
Or s is 7 minus 13, that is minus 6 divided by 2, you get negative.
Negative 3.
And we had negative 10, and we had 10 and negative 3.
Okay.
Okay?
Yes.
Yes. Are you happy now?
Yeah, thank you.
Yes, let us go to the next technique. Unless there are some more questions. So when you're doing factorization, you can always check if you are right or wrong by multiplying out your factors. Okay. The next technique I want to talk about is difference of squares. Difference of squares. This is the third technique actually. Difference of squares. Difference of squares. So what would you get when you multiply a plus b times a minus b? Well, we said that you just take all the components of the first bracket, which is a, and use each of them to multiply the second bracket. So plus b, a minus b. Then do your expansion. A times a, well, that's a squared. A times b, that's ab. B times a, that's ba. B times b, that is b squared. But remember, this is multiplication, and multiplication is commutative. 3 times 2 is the same as 2 times 3. 4 times 5 is the same as 5 times 4. So a times b is the same as ba. So I could write this as a squared minus ab plus ab minus b squared. These are two terms which are additive inverses of each other, so they will get to 0, and you simply have a squared minus b squared. And we started with a plus b times a minus b. So the idea is, when I have an expression that involves a difference of 2 squares, to factorize this, simply multiply the sum of these numbers together with their difference. Let me give you an example. Factorize, let's say 4x squared minus 64. We want to use difference of squares. So first of all, write these terms as a difference of squares. So 4x squared is the same as 2 times x raised to 2. 64 is the same as 8 squared. Then using the rule that we have here, so let A be 2x, let B be 8. So that 2x squared minus 8 squared is going to be A plus B. So A is 2x, B is 8 times A minus B. Okay? But of course, you can factorize this further. Remember, in 2x and 8, 2 is a common factor. So you could have 2 into x plus 4 times 2 into x minus 4. This becomes 4 into x plus 4 x plus 4. So that you get the complete factorization. So when you are given a difference of 2 squares, the factor is simply the product of the sum of those numbers and the difference of those numbers. For example, 4x squared, you could write this as 2x, the whole bracket squared, minus 8 squared, because 8 squared is 64. So then, using this rule, take A to be 2x and B to be 8. The factorization of this is just a product of their sum and their difference. Second example.
Excuse me, sir.
Yes.
Can you end it at 2 in brackets x plus 4 and 2 in brackets x minus 4? Or is it a must for you to end it at 4? Can you end it there?
You can end it here, it's okay, there's no problem.
Oh, okay.
Yes. Maybe another example. This technique will be useful in very many contexts. And another reason why we're doing factorization is because we want to find roots of polynomials. We'll look at that later, roots of equations. We want to look for roots of these polynomials. One of them is factorization. Example 2. Let's say you want to factor x plus t squared minus 4k squared. Factorize this, x plus t squared minus 4k squared. This can be written as a difference of squares. So you could write this as x plus t squared minus 4 is the same as 2 squared. So this becomes 2k squared. Well, we know that a squared minus b squared is simply a plus b times a minus b. So in this case, let a to be x plus t and let b 2k. Then x plus t squared minus 4k squared is the product of a plus b. But what is a? A is x plus t, b is 2k. So that's the sum, and then the difference of them, x plus t minus 2k. Very easy. Just take the terms, multiply their product, multiply their sum, and difference. This is how you factorize difference of 2 squares.
So sorry, just repeat all that again.
This example?
Yeah.
Yes.
The whole example. Okay, let's do it once more. We want to factorize x plus t squared minus 4k squared using difference of squares. So the first thing is to express this the form a squared minus b squared. Write it first as a difference of 2 squares. Then you realize that 4 can be written as 2 squared. So the same expression is x plus t squared minus 2k in bracket squared. So remember, 2k squared is the same as 4k squared. So we are using the rule that a squared minus b squared is a plus b times a minus b. And we have shown this. We showed this by multiplying the right-hand side, and we are arriving at the left-hand side. So these two expressions, this statement is actually true for any real numbers a and b. So then let a to be x plus t, because we want to use this rule, and in this case, our a is in the first bracket, which is x plus t, b is in the second bracket, which is 2k. Then the factorization is simply a product of the sum of these components, x plus t plus 2k, in bracket, then times x plus t, and then minus 2k.
So how did you write b plus b is equals to 2k?
Exactly. What's b plus b?
What is b plus?
B plus b is equals to 2k.
Why is p?
Let, that is let.
Yeah.
Yeah, when you're substituting.
Oh, okay. What I'm trying to do is that I'm trying to write this expression. The rule we are using is that a difference of squares, a squared minus b, factors out as a plus b times a minus b. This is what I know, and I want to use this to factorize something else. Okay, so I'm using what I know to solve a different problem. So if I was to write this expression in this similar form, then my a will be the guy in the first bracket, which is x plus t. So that's why I'm letting a to be x plus t. And then b will be what is in the second bracket, which is 2k. So that's why I'm letting b to be 2k. Then I know the factorization should be a plus b times a minus b. But a is x plus t, so I have x plus t plus b, so that is plus 2k. And then times a, which is x plus t, minus b, but b is 2k.
I think that's what they're trying to say. So then you should just write b is equals to 2k, not b plus
Yeah, b is equals to 2k, not b plus b is equals to 2k, or?
That is
Let b
Sorry.
is equals to 2k.
This is let. This is not b plus b.
Acha.
Sorry about that. That was just a miss. This is not b plus b. Is that all?
I'm confused.
What I'm doing is this. This is your a, and this is b. So instead of having s squared minus b squared, you have x plus t squared minus 2k squared. Are we good? Can we proceed? Did I confuse you?
Yes.
Where did I confuse?
Yes, I'm confused.
Where do you go? What confuses you? Where do you
I
get?
feel like, does it have to be, I think you doing the x plus t squared minus 2k
So
squared.
should I
is
do
what
another
makes it
example? Is it
complicated.
this example that is confusing you, or the?
Yes.
It
It's the
makes it
example.
confusing. Maybe use a simpler example.
Okay. Let me give you another example.
Wait, but sir, I have a question before you continue. So like that's equation that you get, you leave the answer as, how do you leave the answer as the, like how do you factorize, how would you factorize it to get the answer?
My answer will be factorize completely. Make sure that in your final answer you cannot factorize anymore.
So like sir, over here in that one, when we reached x plus t plus 2k brackets, x plus t minus 2k brackets, that's the final answer, because you can't factor, there's nothing to factorize after that.
Exactly. That's the final answer.
Oh, okay, thank you.
Yes. Okay, so let me see. X squared minus 4. We want to factorize x squared minus 4. Or maybe let's factorize x squared minus 1. You have said I use a simple example. Factorize using difference of squares. Using difference of squares. What does the difference of squares say? That if you have any number a squared minus b squared, this can be factored as a plus b times a minus b. Okay? So the first step, write this expression as a difference of two squares. So make sure in the first part you have a square, second part also you have a square. So x squared minus 1 is the same as x squared minus 1 squared. 1 squared is 1. So in this case, a is x and b is 1. So your factorization, x squared minus 1 will be x plus 1, that's a plus b, times a minus b, which is x minus 1. And you can confirm by multiplying these factors, these linear factors, to see if you get back your original expression.
So I have a question.
Go ahead.
So technically the 1 in the equation x squared minus 1 is a negative. But it doesn't appear, or rather I feel like it has been omitted somewhere along. Is it because negative times negative, or
which one?
At x squared minus 1, isn't the 1 a negative?
Yes, this is negative 1. This is x squared minus 1.
So, but like in this, so has it been omitted somewhere because of the square? Because when after negative 1 squared, it kind of disappears unless we move to the last bracket.
1 squared is the square. Do you agree with this expression?
Yes.
Yeah, so I've just replaced this 1 with 1 squared.
Okay.
Why? Is it a must? Yeah, why?
Why? Because I want to write is a difference of squares. I'm factoring a squared minus b squared. So the first one is already in a square, x squared. The second one is not a square. So I want to, that's why I'm writing 1 as 1 squared. Because this technique only works when your expression is a difference of two squares. Difference of two squares, something squared minus something else squared. In this case, a squared minus b squared. So if I want x squared minus 1, I want to factorize this using a difference of squares. I first start by writing this expression as a difference of two squares. So the first term must be a square, the second must also be a square. That is why if I give you something like x squared minus 16, then you must write this as x squared minus 4 squared, so that you are taking a difference of squares. The first term is a square, the second term is also a square.
Okay, I get it.
Okay, let us move to the next technique. Let me see how much time we got. Okay. That was number 3. Number 4, actually handle them together. Sum and difference of 2 cubes. Sum and difference of 2 cubes. So we have just dealt with the difference of squares. Now we look at sum and difference of 2 cubes. So firstly, because we have dealt with the difference before, let's look at difference of 2 cubes. And what you should remember is a cubed minus b cubed is going to be a minus b times a squared plus ab plus b squared. Why is that true? That is true because if you multiply this right-hand side expression, you will get the left-hand side. So let's do that. We want to multiply a minus b times a squared plus ab plus b squared. Well, this is just a into a squared plus ab plus b squared. I hope you're now very comfortable with multiplication of these polynomials plus ab plus b squared. So we are going to expand this and then combine the like terms. So a times a squared is a cubed. A times ab is a squared b. Okay. What is the next term?
AB squared.
AB squared.
AB squared.
AB squared. Then next we have
BA squared.
A squared.
BA squared, and then
AB squared.
AB squared.
AB squared, and then lastly
B
B
cubed.
cubed.
then you realize that a squared b is the same as b squared, and ab squared is the same as ab squared. So this is going to be a cubed plus a squared b. I want to write combine the like terms, minus a squared b plus ab squared minus ab squared minus b cubed. So these two guys are additive inverses. So this will go to 0. These are also additive inverses. So we end up with a cubed minus b cubed. So this expression is true for any real numbers a and b. Now we want to see how to use this expression to factorize a difference of 2 cubes. So example, factorize x power 6 maybe minus 8. Factorize x power 6 minus 8 using difference of cubes. Using difference of cubes. Okay, so the first step, you don't need all this. This was just verifying that this statement is true. You only need to remember this expansion, but a cubed minus b cubed is a minus b times a squared plus ab plus b squared. Okay, so the first step, as we are doing with difference of squares, make sure this is in the same form. It's a difference of cubes. So you can write x power 6 as x squared cubed minus, you can write 8 as cubed. So here x power 6 is the same as x squared cubed, and 8 is the same as 2 cubed. That is the first step. Write it as a difference of cubes. Then identify your a. So in this case, a is x squared, b is 2. Well, therefore, x squared minus 8 is going to be a minus b. So this is x squared minus 2 into a squared. So we take x squared squared plus ab. So that is just going to be 2x squared plus b squared. So that is 2 squared. This is going to give you x squared minus 2. Well, x squared squared is just x to the 4th plus 2x squared plus 2 squared is just 4. And you can leave your answer at this stage.
Excuse me, sir.
Go ahead.
So once we are able to write them as cube, as differences of cubes, we don't need to add the cubes to the equation, because I see after that you just didn't use any cube anywhere.
No, writing is as a difference of cubes is just so that you use this formula. Look at this as a formula. That a cube minus b cube is a minus b times x squared plus ab plus b squared.
Okay.
Yeah, writing as a difference of cube is just to identify it with this formula.
Okay.
Do you want another example? Is that okay?
Yes, please.
Yes, please.
So I've got a small question.
Yes, go ahead.
So there you said let A be x squared and B be 2. So can you interchange them? Is it fine?
No, don't interchange them. When you interchange them, you will encounter sign problems. So you will, for example, if I interchange, yeah, we can do that and see what you get. Huh? Okay.
But if you can, you don't need to prove it. But then if I don't know, okay.
Yes, if you change, you're going to encounter a sign problem. You'll get a different. You'll get the
okay.
this expression.
Okay, so it's better if you make the x's and the y's, be the a and the numbers be
In
b's.
this case, for those of you who want to try, go and try interchanging a and b. You realize that when you expand your final expression, you'll end up with 8 minus x power 6, not x power 6 minus 8. If you interchange a and b at this stage, you'll end up factoring a minus x power 6 instead of x power 6 minus 8. Just go and try this. Go and try this at home. And tell me what.
Okay. Thank you.
Example, let's have 27 x cubed minus 1. For the first step, I said, make sure you have cubes in both terms. So 27x cubed is the same as 3x cubed minus 1 cubed. Remember, 1 cubed is just 1 times 1 times 1, which is 1. So now, in this case, using the formula, a is 3x and b is 1, okay? So that 27x cubed minus 1 will be a minus b, so that is 3x minus 1. And then a squared is 3x squared plus ab 3x plus b squared. So this gives you 3x minus 1 to 9x squared plus 3x plus 1. Of course, here I'm stopping at this stage, but remember you can go ahead and check if this can be factored using these are trinomial. We have just done factorization of trinomials. You can go ahead and check. And I want to warn you that not all these expressions will have factorizations. Some of them cannot be factored. And if we have time, we will look at the fundamental theorem of algebra, and which of course takes you to Galois theory for these algebraic equations. If you get time, we will reach there. But just to warn you that not all expressions or all polynomials can be factored. There are some which cannot be factored, and we will refer to them as irreducible polynomials or expressions. But that should not worry you. To test your understanding, I'll always give you expressions which have worked out and seen that they can be factored. Okay. Is there any question before I proceed to the next? Yes.
Yes.
Go ahead.
Yes, you said here. Are you getting me? Are you hearing me?
Yes, I'm getting you.
Okay. You said when we go home and change change it around, we get 8 minus x to the power 6, right?
Yes, when you interchange A and B in that particular example.
Okay. So if we do the other examples, we get the same different answers too. If we change A and B around.
Sorry?
As if we change A and B around for the other examples, we get different answers too.
Yeah, if you change for the other example, you get different answer, which is just a negative. It's just having a factor of negative one, because 8 minus x to the 6 is simply -1 into x to the 6 minus 8.
Sir, 3x bracket 3x squared, is it 9x squared? I thought it's just 9x.
3x squared. 3x squared. Huh? Okay. This is the same as 3x times 3x.
Oh, okay.
3 times 3 is 9. X times x is x squared.
Okay.
Okay, let's look at sum of cubes now.
Before you continue.
Sorry?
Before you continue.
Yes, go ahead.
You said a cubed minus b cubed is equals to a minus b into brackets, into another brackets, a squared plus ab plus b squared.
Yes.
Okay, thank you.
We even showed that. Yeah. Now next is sum of cubes. So you want to factorize things like a cubed plus b cubed. And remember, a and b are just dummies. You can use any other two letters you like, maybe x and y, p and r, j and h. These are dummy variables. The meaning of the expression does not change if we use different variables. So this should be a plus b times a squared minus ab plus b squared. Of course, to confirm if it is true, just multiply the term on the right hand side and check if you get what's on the left hand side. So I will take a into a squared minus ab plus b squared, 12 plus b into a squared minus ab plus b squared. So a times a is a cubed, a times a squared, a times ab, so that's a squared b, and then a times b squared is ab squared plus b times a squared, that is the same as a squared b, minus ab squared plus b cubed. And then you realize that a squared b minus a squared b will give you 0. ab squared minus ab squared will give you 0. So you end up with a cubed plus b cubed. So it's true that this expression is satisfied for any two real numbers a and b. Example. So this is going to be like a formula for factoring sum of cubes. Just take the sum of the numbers and then multiply by the difference of the sum of their squares and their product. For example, we can do 27x cubed plus 1. In the previous example, we did 27x cubed minus 1. So you can write this as 3x cubed plus 1 cubed. Then a is 3x, b is 1. So according to the rule, factoring sum of cubes, 27x cubed plus 1 is going to be a plus b, which is 3x plus 1, times a squared, so that is 9x squared, minus ab, so minus 3x plus 1. That will be a factorization. Once you have identified your A and B, just plug into the formula and
The camera is blurry.
camera is it okay now?
Yes.
Again, is it okay?
It is for me.
It's okay for me too.
Okay for me too.
There's someone who raised a concern.
Fine for me.
I hope it's okay now.
Yeah.
Ah, good. You need another example?
So in this other example, when you have 3x cubed plus 1 cubed, how does A just become 3x and B is just 1?
B is just 1.
Yeah.
Remember,
Like they were cubed and now they're not.
I'm trying to write this as A cubed plus B cubed. So here what is cube is 3x. That becomes here. Here what is cube is 1. That becomes here. Did I convince you?
Instead of writing ax, is it okay to also write 3x then? 3x cubed minus 3x plus 1.
Wait a minute. 3x here.
Yeah.
Yeah, this is 3x squared.
Oh, okay. So you just substituted it, like you just put it there. That's what.
Because 9x squared is, so 9x squared is the same as 3x. This is 3x squared.
Okay, yeah. I was just asking
No,
to
this is
confirm.
1 squared. 1 squared is 1.
Okay.
Yes. Okay, let us move to another technique. I don't know whether we have enough time. Let us move to another technique. That was 4. Number 5. Perfect squares. Perfect squares. So we have looked at common factors, difference of squares, difference of cubes, and sum of cubes. Now we have perfect squares. So after this, there's only one technique remaining, which is dealing with exponents which are not necessarily integers. They could be fractions. But first, what's a perfect square? Before defining a perfect square, I would like us to work out the following. A plus B squared. This is going to be A plus B times A plus B, okay, which is A plus B plus B to A plus B. So A times A is A squared, A times B is AB, B times A is BA, B times B is B squared. But remember, multiplication is commutative, so AB is the same as BA. So this is A squared plus AB plus AB plus B squared. So this gives you A squared plus 2AB plus B squared.
Again.
Then the other one that we need is A minus B. A minus B. A minus B. So this is A minus B. Okay, and then minus B, A minus B. Then we just expand. Okay, so A times A is A squared. So minus AB, then minus BA, and then negative times negative is positive, so we have plus B squared course, for the same reasons here, we will have a squared minus ab minus ab plus b squared. I'm doing this because multiplication is commutative. Multiplication for real numbers is commutative. And so this is a squared minus 2ab plus b squared.
Do you leave your answer in this format, like the long format?
Sorry?
Do you leave your answer in like the expanded form?
Which
Or
expanded form?
Back to
No, this is not factorization. I'm just setting ground for factorization using perfect.
Factorization.
This is not, we have not started factoring anything. We're just setting a ground. We're just motivating how to factorize perfect squares. Okay? I've not even defined what's a perfect square, but I need this to define that. So I want you to make an observation. When you are squaring a sum of two numbers, okay? So let me write down here. A plus b squared. So there, a squared plus 2ab plus b squared. When you're squaring a sum of two numbers a and b, then the result will be sum of the squares of the numbers, the square of a plus the square of b, and then plus twice the product. The product is ab. Then when you're squaring a difference of two numbers, the result is sum of the squares, you subtract twice their product. Okay? So we will have expressions or polynomials which take this form. Any expression or polynomial of this form or of this form is what we will call a perfect square. Of course, we will come back to perfect squares when solving quadratic equations, because one of the ways of solving quadratic equations is by completing the square. So definition, a perfect square is any expression of these forms. So shall I write this?
Yes.
A perfect square is any expression the form a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. And once you know how we got this, we expanded a plus b squared. And how we got this, we expanded a minus b squared. So once you know the expansion of a plus b squared and a minus b squared, then given this, to go back to the original form, we know this is a plus b squared, this will be a minus b squared. So we're going to use this technique to factorize expressions which are perfect squares. For example, now we have factorized this example before, x squared plus 6x plus 9. We factorize this by, was it by grouping or? Yeah, there's a trinomial we factored like this before, just today, x squared plus 6x plus 9. Okay, so remember you can write this as x squared, of course there's a 1 squared plus 2 times 3 times x plus 3 squared. 1 squared times x squared is just x squared. 2 times 3 times x is 6x. 3 squared is 9. Of course, because this is positive, so if I let my a to be I don't need this one. X, let my b to be 3, and then so this is in the form It's in the form a squared plus 2ab plus b squared. And we know that the factorization of this is a plus b squared. So that means x squared plus 6x plus 9 is the same as x plus 3 squared. So any expression that can be written in any of these two forms is a perfect square. And to factor this, just identify your a and b. You know that when you have this middle term positive, that's a plus b squared. When you have the middle term negative, that's a minus b squared. Let me give you another example. Still with me.
X times 3x.
Are you there?
Yes.
No.
Yes, we are here.
Oh, okay, that's good. Let me see. Yeah, so factor something like 4x squared minus 4x plus 1. Of course, this is a perfect square because you can write this as 2x squared minus 2x times 1 plus 1 squared. So your a is just 2x, b is just 1. And because the middle term is negative, so we know that 4x squared minus 4x plus b will be 2x minus 1 squared.
Excuse me, sir. Why is there 1 plus 1?
Where?
Right after 2 into bracket 2x.
Times 1, so there's 1 outside the bracket. This is the one outside this. 2 times 2x times 1, then plus 1 squared also. Yeah, I'm just trying to, so at this stage, I'm just trying to write it in the form a squared minus 2ab plus b squared.
Excuse me, sir.
Remember, this is my a. This is 2. This is my a. This is my b squared. But excuse.
Yeah, so the first example that you gave, you said that it's a squared minus b squared that is equal to a squared minus 2ab plus b squared. So now when you write your final expression there, that is in brackets 2x minus 1
I did get your first
squared.
You said a minus b?
No, I said because the first the formula you said a squared minus b squared is equals to a squared minus 2ab plus b squared. That is when we are working with the
A
difference.
squared minus b squared. You're saying a squared minus b squared is equal to?
A squared minus 2ab plus b squared. That is like the perfect square. I'm talking about the perfect square.
Perfect square.
Okay, is equals to a squared minus 2ab plus b squared.
This is not true. This is not true.
Okay.
I know. Don't confuse these two expressions. Huh? Don't confuse a difference of squares and a perfect square. So under difference of squares, we talked of a squared minus b squared as a plus b times a minus b. This was difference of squares. And now in perfect squares, we need a plus b squared. This is a squared plus 2ab plus b squared. Then a minus b squared is a squared minus 2ab plus b squared.
Oh, I get it. I get it now. Yeah.
The
Thank you.
expressions that take the last two forms, let me call this 2 and 3. Expressions that take the form 2 and 3 are what we are referring to as perfect squares. So your goal is just to identify if it's a perfect square. If it's a perfect square where the middle term is positive, then you know you will have to square a linear factor which is a sum. And then if it's a perfect square of the form 3 where the middle term is negative, then you will have to square a linear factor which is a difference. So a minus b squared and then a plus b squared.
Yes, thank you. I get it.
And the part, how is b 1?
Sorry?
How is b equals to 1?
Could you speak louder? How is b equal to?
1, yes.
Yeah. Yeah.
No, when you put a equals to 2x and b equals to 1.
Yes.
Where is the 1 from?
1 is this one. Let's go over this again. You can repeat this quickly, it's no problem. So this is a perfect square. It's actually of this second form. So I just need to identify what's a and b, and I'm done. 4x squared is the same as 2x squared minus 2 times 2x times 1 plus 1 squared. Remember, 1 is the same as 1 squared. 1 squared is 1. Do you agree with this statement?
I mean, where did that 1 come from behind that 2x?
Where the 1 comes from? This one.
Yes.
I don't get what you're asking. Are you asking about this one?
Yes.
Yes.
It doesn't change anything. Anything times 1 is 1. A times 1 is A. 2 times 1 is 2. It doesn't change anything.
Yes, sir.
I'm just putting it there. So let me tell you why I'm putting it there. Because I want this expression to be in the form a squared minus 2ab plus b squared. So when I write it like this, I can identify 2x with a. Oops, this one is not working. I can identify 2 with 2, then 2x with a, and then 1 with b, and then lastly 1 with b. I'm just trying to write this expression in this form so that it becomes easier for me to choose an A and a B. Is that fair enough?
Can I ask something, sir?
Yes.
When you give us a problem to solve, will you be like, will the question include the formula we are supposed to use?
No, I will not include the formula. I will just give instructions. I will just tell you, factorize this using difference of squares. Sometimes I will not give you instructions, so it will be upon you to identify which technique you use. Remember, this is mathematics. Any technique for factorization, if it can work for that expression, you'll get the same answer. Whether you use common factors, whether someone uses trinomials, whether someone uses difference of squares, sum of squares, difference of cubes, sum of cubes, you will get the same result as long as you are you apply the rules consistently. So I may or I may not. So if I want to test whether you understood difference of cubes, then I'll be specific. Use a difference of cubes to factorize this. If I want to test if you understood perfect squares, factorize this as a perfect square. But I could also leave the question open so that it will be up to you to choose the method that you will use.
Okay, thank you.
Yes. Any more questions?
No.
No questions. So in the next class, we will look at factorization of factorization of expressions which involve fractional exponents.